I want to eliminate z from another pair, I'm going to choose to use equations 1 and 3. 1 and 3. So, we'll choose 1 and 3 and eliminate z. I'll copy equations 1 and 3. Equation 1 is 2x plus 3y minus z equals negative 8. Equation 3 is 3x minus y plus z equals 9. Since I'm eliminating z, I want the coefficients of z to be opposites, but they already are, negative 1 and positive 1, so that when I add them, these will cancel. That gives me, as the sum, 5x plus 2y equals 1. 5x plus 2y equals 1. This gives me equation number, what are we up to now? Number 5. So here's an equation, equation number 4, that has the variables x and y. Here's another equation, equation number 5, that has the variables x and y. 2 equations, 2 variables. I have a 2 by 2 system. Equations 4 and 5 make a 2 by 2 system. And so I copy them and make the system 5x plus 4y equals negative 3, 5x plus 2y equals 1. What we have done, you notice, is to begin with a 3 by 3 system, and by careful elimination of a letter from different pairs of equations, I've gotten down to a 2 by 2 system. Now all I have to do is solve that system. So let's solve this system using the addition method. I'm going to choose to eliminate x because I have 5x and 5x. That will be so easy. Let me choose to multiply the top equation by 1 and the bottom equation by negative 1. So the top equation remains as it is, 5x plus 4y equals negative 3, and the bottom equation is negative 5x minus 2y equals negative 1. Now we can cancel the x terms, and adding we get 2y equals negative 4. And now we're home free. All we have to do is divide both sides by 2, and then we get y equals negative 2. So here is an answer for y. Remember that this answer for y is half of the solution of the 2 by 2 system that I've just created. So all I have to do is finish that 2 by 2 system solution. We've found the y value, let's find the x value. I'll choose one of the equations and fill in the negative 2 for y. So I'm going to choose the first equation, 5x plus 4y equals negative 3, and fill in the negative 2. 5x plus 4 times negative 2 equals negative 3. That gives me 5x plus negative 8 equals negative 3. And then I'll solve that equation. We'll eliminate the negative 8 being added on both sides, on the left, by adding positive 8 on both sides. We get 5x really plus negative 8 is subtract 8. 5x minus 8 plus 8 equals negative 3 plus 8, and that gives me 5x equals 5. And that one, when we divide by 5, clearly gives us x equals 1. So the 2 by 2 system solves to give the x value of 1 and the y value of negative 2. We've got x and y both determined. All that's left is to find z. And so we back substitute to find z. Back substitute to find z. To find z, we must use one of the original equations and fill in the numbers that were given so far. Let me put back up here on the screen the original system. The original system was 2x plus 3y minus z equals -8, x minus 2y plus 2z equals 13, 3x minus y plus z equals 9. Which of these do you think would be easiest to use to find z? If we want to find z, it's not going to be very difficult for any of them. But notice that the third equation has z with a positive 1 coefficient. Think about that. If you have 1z equals a number, then that tells you what z is automatically. So our easiest choice would be to use equation number 3. So I'm going to do just that. Use equation number 3, 3x minus y plus z equals 9, and back substitute to find the z value. Well, for our back substitution, we have 3 times the unknown x minus the unknown y plus z equals 9, but we do know the x and the y. The x value is 1, and the y value is -2. And so that gives us 3 times 1 subtract -2 plus z equals 9, which gives us 3 plus 2 plus z equals 9, or 5 plus z equals 9. To get z by itself, all we must do is remove the 5 from the left by subtracting 5 from both sides. We get 5 plus z subtract 5 equals 9 subtract 5. And that gives us z equals 4. And so our z value of 4 has been obtained, and the solution is the ordered triple 1, -2, 4. Remember, you have to list these in alphabetical order: x, y, and z. Up to this point, we've only had ordered pairs, which we wrote in the order x and then y. Now that we have the letter z, it simply follows in line: the x, then the y, then the z. So our ordered triple is always in the order x, y, z, alphabetical order. We found the solution. The only thing left is to check it. Before we check, let's review briefly the steps that we took. We paired up 2 of the equations, eliminated a letter. Paired up another pair of equations, eliminated the same letter. That gave us a 2x2 system. So we go from a 3x3 system down to a 2x2 system. Let's summarize this. We have a 3x3 system. We go from there to a 2x2 system. In the 2x2 system, we solve. Once we solve the 2x2 system, the only thing left is the remaining letter, and so we back substitute. Back substitute to get the remaining letter. From a 3x3 system to a 2x2 system, which we solve, then we back substitute.